Good morning and welcome to the 2026 AAAS annual meeting SciMike stage, supported by the George Washington University. This is being streamed online, but we're also presenting it in person here in Phoenix. I am your host, Jessica Hubbard, and we are continuing our slate of interviews this morning. I'm here with Saptaparna Bhattacharya, Assistant Professor at the Southern Methodist University, Department of Physics and Astronomy. Welcome to the SciMike stage.
Thank you very much for having me.
Tell me a little bit about yourself.
Of course. I am an assistant professor at Southern Methodist, as you said. I obtained my PhD from Brown University in particle physics. I've been a particle physicist throughout, and I can tell you a little bit about what I do. I have some slides there. So this is typically the kind of slide I use to recruit people in my group. So it kind of tells you what I do, essentially. So I work on the data from the Large Hadron Collider at CERN. And what we are doing there is we are collecting the data from the collisions that happen where there are two counter-rotating beams of protons that collide at the highest energies ever achieved in any experiment. And as a result of this, we collect this beautiful data, which we then analyze in great detail. So you can see the pictures there. And the kind of physics that I do is looking for ultra-rare processes, so looking for ultra-rare physics. And if you look at the picture on the right, we saw only 3 such events in all of the data set that we had analyzed so far, till the time we published it. So this is ultra rare, and that's why I rely a lot on AI/ML techniques to augment my sensitivity to these new processes. And this is discovery science.
This is really cool.
I have more slides. Would you like me to keep going?
For sure, yeah.
All right. So, specifically, I'm interested in the production of 3-gauge bosons. So I don't want to go into the detail of what a gauge boson is, except to say that it's a fundamental particle. And so just to give you an idea of how hard it is to find these kinds of gauge bosons, more than one gauge boson in an event. So the first time a single gauge boson was found was in 1983, and the Nobel Prize was given the very next year. It was one of the fastest Nobel Prizes in history. Then
wow.
Yes. Then the pairs of gauge bosons were observed in 1997, and then it took us a long time to get to observing 3 of these gauge bosons being produced in one collision event. So this is, as I said, ultra rare, extremely challenging, but extremely rewarding kind of physics that we do.
And you'll be talking a little bit more about this in your session, correct?
Yes. So I'm going to talk about, also I actually had another...
Go for it. No, that's totally fine.
Physics is so interesting. Yes, so I just wanted to show off my new results. So this is what we just published. So I'm actually switching from one experimental collaboration to the other. So this is part of my older work, but I'm very proud of it. It took a long time to get to this result, but it is a beautiful, beautiful event that is there where you see these cones. They represent 3 different particles that the gauge boson decayed to, and then you see those red kind of slabs. So that's like the furthest part of the detector where we detected a particle that arose from the decay, and it's extremely rare. We did not think we would actually find such an event, and when we looked at the event, we realized that we found something very interesting, and it was very rewarding.
Really cool. Just to reiterate, your session is later today, right?
Yes, indeed. Yes.
And it'll be going over this as well.
Exactly.
Yes.
So I'm going to talk about my research in the context of global science.
Okay, perfect. Yes. I'm getting excited just listening about this. So what excites you about doing this work?
Oh, many reasons. The best part of doing research in particle physics is that every single day I think I get to learn something new. I'm constantly learning new things, and I'm constantly sort of transmitting that knowledge to my group. And I learn from them. So it's a exchange of ideas, it's a field because it's so huge. What we do spans so much. It's a giant experimental complex. We're doing various kinds of physics. It is just so big in its scope that there's so much to learn.
So much to learn. I love that. When did you first realize that you wanted to pursue this line of work?
Oh, so this is going to sound very cliched, but since I was a child.
Oh, same for me as an atmospheric scientist. It was the clouds for me. So yeah.
I wanted to pursue physics. I was always excited. My mother knew that I wanted to be a physicist, and she also knew that I wasn't very good at math. So she got me a math tutor who was actually a professor of physics, and he would come home to teach me math. And he later confessed that all he did was sit next to me and encourage me. Apparently that's all I needed. But eventually I became good at math, and then my math sort of caught on with the physics, and I was able to pursue a career in physics. So, if you feel a little shaky about your math, don't worry. You'll always pick it up.
And I feel like it illuminates the importance of mentorship in a way,
Yes.
in a way, right? So how has that played a role in maybe your field? You just talked about it a little bit in your own work, but maybe in your field or, in your career itself.
Yes. So, I have built a research group. So as you said, I joined Southern Methodist in 2024. So I'm a fairly newly minted assistant professor. I am in the process of building my group. I already have 2 postdoctoral researchers that are based at CERN. And yes, there's constant exchange of ideas. And the other thing I do is I always try to make sure my students get to visit the experimental complex, so they get to go to and see the experiment, and they also get to go to the national labs that are so crucial to our research. So my weekends are spent writing letters of recommendation to send my students to different places, like literally. So I am writing a letter of recommendation. I just submitted an application to send my student to work at Berkeley Labs, and a colleague of mine said that folks from NVIDIA will be visiting Berkeley Labs. So my student gets to work on our GPU code with people from NVIDIA. I told him this is like working at NASA during the heyday of the lunar program. This is incredible.
It's so awesome. And we have students who are attending this conference, and they may be listening now or attending the session later. What advice would you have for them who sees this work and thinks, wow, I want to do that. That's so cool.
I would say that, take STEM classes, take math, physics classes, go beyond your regular curriculum. There's so much that you can, subscribe to one of these AI models like Gemini or, ChatGPT and use it to really learn new things. There's so much that these AI models can do, and also learn how the AI works. Not just be a user, but actually learn how it works. And, I think reading, just when I attend these kinds of events like this one here, go to conferences, go to listen to public lectures. I think I learned a lot through public lectures. At least I knew that this is the field I wanted to be in, because it's so exciting, so much is happening all the time.
You mentioned, STEM classes, skills that are important for your work. Are there any skills that have been important that people might not expect to be important for your work?
Yes, so I work in a giant experimental collaboration of more than 4,000 people.
Wow.
So I'm constantly talking to people, meeting new people, and I think being good, the soft skills matter. How you collaborate with others, being open to collaborations, and also being open to travel. Traveling on short notice, being willing to travel, to talk about you, and the ability to convince other people of the correctness of your work. That is actually a very important skill. Be giving good presentations.
Right. I call this the final phase of the interview, where, we're scientists and we do science, but we're humans, so there's other things that are a part of our lives, right? Is there anything that you're either reading right now, or any hobbies that have brought you joy in your life?
Right. So I don't always have a lot of time for reading, and I think that's kind of common here. And, I thought that if you'd asked me this question, I'd say, well, I read my own research papers, and when I do read my own research papers, I come up with editorial comments, as I'm constantly correcting, my own work before they're submitted to a journal. But beyond that, I am very interested in history, so I'm constantly listening to podcasts. That's like
Love
the way
podcasts.
I unwind. I also, I know that there's a lot of great science, popular science books. The one that influenced me when I was growing up is the one by Stephen Hawking, Brief History of Time. I think that's a classic. My friends have said that Simon Singh's book on the Big Bang is great. I haven't read it myself, but I've heard great things about it. And of course, Brian Greene's book. The Fabric of Reality. I think they're all great books. And Brand Green, of course, has a connection to AAAS, of course.
My reading list continues to grow. Are there any final thoughts that you would like to leave here with listeners in person or anyone who's tuning in online?
I would just say that, if you're a student and you want to do this kind of research, then learn a little, the ways that I told you about using all of the AI tools. There's so much material out there. And if you really want to do research, just reach out to me even, And if you're a professor and you have undergraduates, then please send them my way. I'm very happy to mentor more students. I really find that a very rewarding part of my life. And yeah, I think that would be my general advice to people is just, there's so much going on, and the Large Hadron Collider is an amazing instrument, and it's revolutionizing our understanding of the universe. So yeah, listen to all the things that we, all of our results that we put out every now and then, and engage with us.
This has been a great conversation. I really appreciate your time. Thank you so much for joining me on the SciMike stage today.
Thank you very much for this opportunity.
Thank you.